Solar cells, as you all know, are solid-state electrical devices which converts energy of light into electricity. The basic components of a solar panel are a solar cell which is covered by anti-reflection coating, a transparent adhesive and a cover glass. Solar cells could be divided into four types on the basis of arrangement of the crystals, which are monocrystalline, multicrystalline, amorphous silicon, and copper indium dicyanide, which are all basically traditional solar cells. Basically, two types of traditional solar cells. The first is discrete cell technology. It is used where you don't want to figure out the difference between the material and the solar cell. And then we have integrated thin films of solar cell which can be laid on any surface. The research on the solar cells have been going on for quite a long time. Now we have the time of innovations in solar cells. The first is the flexible solar panels, which are very easy to lay.
Hey everyone, I'm here with some flexible solar panels today. These panels come in various sizes, shapes, voltages, so you really get whatever you need. What's different about these solar panels as compared to a lot of other solar panels is most solar panels that you're going to find are really delicate to work with. They shatter easily, they break, but these ones are ridiculously durable and incredibly flexible. For example, this 3.6 watt panel right here, look at that. Fold it in half, twist it around, and you're still going to get the same result that you get from a lot of other panels, except this one is easier to work with. You don't have to be as careful around it.
After the flexible solar cells, we have spherical solar cells.
At PV Expo 2010, Kyocera exhibited solar window glass which generates power using spherical solar cells called Sphela, developed by Kyocera. Sphela are spherical solar cells 1.8 mm in diameter made from solidified silicon droplets. They can be used in various applications, including flexible solar cells where the spheres are arranged on a soft film backing, and dome-shaped modules. Because they are highly transparent to light, these cells are expected to be used in solar window glass. The solar cells can be applied to transparent plastics such as polycarbonate as well as glass, so the flexibility of Sphela could also be utilized in car windows. Sphela cells are manufactured using a special process in which molten silicon is allowed to fall freely, so it naturally forms spheres under weightless conditions. Because there's little material loss in this process, it enables costs to be reduced substantially and silicon to be utilized efficiently.
The latest innovation in the solar cell technology are the transparent solar cells, which has a wide range of applications.
Imagine if your windows didn't just give you a view of the outside world, but also functioned as solar panels, generating electricity for your appliances and home electronics. A recent paper in ACS Nano described technology that could do just that.
My name is Professor Yang Yang from the University of California, Los Angeles. I'm a professor at the Department of Material Science and Engineering. I'm also serving as a director of the renewable energy of the California Nanosystem Institute.
I'm Paul Weiss. I'm director of the California Nanosystems Institute. I'm editor-in-chief of ACS Nano, and I'm also one of the UCLA researchers who helped Professor Yang Yang and his group develop the transparent solar cells.
The research we're working on is actually a plastic-like material serving as a solar cell materials which invisible in the invisible range but pick up the photons in the infrared range. Our solar cells are very different from the traditional solar cell which are opaque and dark color. Our solar cell mainly use the material pick up the infrared light rather than the visible light, so it's rather transparent in the visible range. Therefore, it can be used in different applications than the traditional solar cells. The material is actually a plastic-like materials, so potentially it can be produced in large quantity and low cost.
The advantages of these materials are they're easy to manufacture and thus economical. One of the guiding principles in developing both the windows and the materials in Professor Yang's group was to use common and earth-abundant materials so that these could ultimately be made in quantity. We hope in a few years that these materials will be everywhere on windows around the world, collecting energy while we're able to use those windows for their normal purpose, being able to see through them. We also hope that the solar cells work on devices where we can look at the displays with the visible light, but at the same time, the solar cells are collecting the infrared radiation that we don't see.
Transparent solar panels are able to charge as windows and screens. A Michigan State University research team has developed a transparent solar panel capable of capturing solar energy. Most solar panels capture visible spectrum light, which represents just a small segment of the electromagnetic wave spectrum. Visible light passes directly through the transparent luminescent solar concentrator, but non-visible ultraviolet waves are captured by small organic molecules embedded in the device. The concentrator then converts it into another colorless infrared wavelength and sends it to the edge of the concentrator, where photovoltaic solar cells convert light energy to electricity. The technology could potentially be installed on building windows, screens, and other sunlight harvesting services.